Students, in previous class we discussed about the difference between mixtures and compounds. Okay, we will discuss about the pure substances in this class. So we can define compound as a pure substances that can be separated into two or more components only by means of a chemical reaction. So already starting in this chapter, in first video we discussed compound is also a pure substance. Okay, and these compounds can be separated. How the compounds will form? Compounds are formed atoms of different elements combined together in a fixed ratio, then the compounds will form. Okay, so these compounds are pure substances and that can be separated into two or more components only by the chemical reactions. So this compound is formed by two or more elements now. Okay, so then that can be separated into two or more elements only by the process of chemical reactions. Okay, we now have two types of pure substances. Okay, now we have two types in pure substances. So in the first video we discussed pure substances, again classified into two subgroups. What are that? Elements and compounds. Okay, pure substances are classified into two types. What are the two types? Compounds and elements. These elements can be divided into metals, non-metals and metalloids. So we have already studied the properties of metals, non-metals and metalloids. So in the first video we discussed elements can be classified into metals, non-metals and metalloids, and we studied the properties of metals, non-metals and metalloids in the last year, 8th class, 4th chapter also. Okay, metals are lustrous, sonorous, malleable, ductile, good conductors of heat and electricity. Non-metals are non-lustrous, non-sonorous, non-ductile, non-malleable. Okay, bad conductors of heat and electricity. Okay, so write down the names of some elements that you know. Do you know the names of elements? Will you say? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus. Okay, so these all are the example for metals only. Elements, these all are the example for elements only, sorry, not metals. So till now I said no, that all are the elements only. Okay, elements have been used since the early days of civilization. Okay, so these elements have been used since the early days of civilization. Metals such as iron, lead, copper helped in the development of civilization. So for thousands of years, alchemists up to and including Isaac Newton attempted to unearth a new elements and study their properties. So our chemist including Newton also, so they discovered the elements and they study the properties of elements also. Okay, Henning Brad, a German alchemist, boiled down urine to discover the phosphorus in 1669. Okay, Henning Brad, a German alchemist, boiled down urine to discover the phosphorus in 1669, but it was not until the late of 1700 years that our knowledge of the elements really took off as alchemists to develop a new ways to purify and isolate elements. By the 18th century last, our alchemists discovered the purification methods and how to separate the elements. The techniques they developed, by that the knowledge about the elements came. Okay, so Sir Humphrey Davy was extremely successful in discovering many elements like sodium, magnesium, boron, chlorine and many more. And Robert Boyle used the term element, and Lavoisier was the first to establish a useful definition of element. So he defined an element as a basic form of matter and it cannot be broken down into a simpler substance by any chemical reactions. So Robert Boyle was using the term element and Lavoisier was the first to establish a useful definition of element. He defined an element is the basic form of a matter and it cannot be broken down into simpler substances by the chemical reaction. If any substance can be separated into two or more constituent parts by a chemical reactions, that substance is definitely a compound. So this chemist, they said the definition of element like this: element is the basic form of a matter and it cannot be broken down into simpler substances by any chemical means. If the substance is separated into two or more constituents by the chemical reaction process, then the substance is definitely called as compound. So what do we get when two or more elements are combined? So we can understand through an activity. Understanding the nature of elements, compounds and mixtures. So now we will discuss about the nature of elements, compounds and mixtures. So divide the class into two groups. Divide the class into two groups and give 5 grams of iron filings and 3 grams of sulfur powder in a china dish to the both groups. Give 5 grams of iron filings and 3 grams of sulfur powder in a china dish to the both groups. And the activity for group 1. Okay, and we divided the class into two groups, no? So say this activity, say to first group to do this activity. Okay, mix and crush iron filings and sulfur powder. Okay, say to first group to do the here we are given 5 grams of iron filings and 3 grams of sulfur powder, no? And say to the first group to mix and crush the iron filings and sulfur powder. Okay, mix and crush the iron filings and sulfur powder. Check for magnetism in the material obtained. So bring a magnet near the material and check if the material is attracted towards the magnet. Okay, say to the first group to mix and crush the iron filings and sulfur powder and check for magnetism the material obtained. After mixing and crushing they will obtain material, no? Check the magnetism of that material. So to check it magnetism, bring a magnet near the material. Okay, so the material is attracted towards the magnet or not observed. Okay, and activity for second group. Okay, say to second group, mix and crush the iron filings and sulfur powder. Heat this mixture strongly still it becomes red hot. Say to the second group, mix and crush the iron filings and sulfur powder and heat the mixture strongly, okay, till it becomes red hot. Next, remove it from flame and let the mixture cool. So now remove it from flame and let the mixture to cool. Check for magnetism in the material obtained. So check the magnetism property, the material which is obtained. So now compare the texture and color of the material obtained by the two groups and after some time obtain the color and texture of a material obtained by the both groups. The next part can be done if we have lab setup in the school. So the next part we should done if we have lab in our school. Okay, so what are the steps? See here, each group should divide the material obtained into two parts. Each groups divide the material obtained into two parts. Each group should divide the material obtained into two parts. Add carbon disulfide to one part, stir well and filter. Add carbon disulfide to one part and stir it well and filter. Okay, next add dilute sulfuric acid or dilute hydrochloric acid to other part. Add dilute hydrochloric acid or dilute sulfuric acid to other part. Do the same reactions separately with sulfur and iron. Observe the changes. Here each group should divide the material obtained into two parts. Add carbon disulfide to one part, stir well and filter. Add dilute hydrochloric acid or sulfuric acid to the other part and do the same reaction separately with sulfur and iron. Observe the changes. Now answer the following. Did the material obtained by the two groups look the same? Which group has obtained a material with magnetic property? Can we separate the components of the material obtained? On adding dilute sulfuric acid or dilute hydrochloric acid, did both the groups obtain gas? Did the gas in both the cases smell the same or different? So here the gas obtained by group 1 due to the reaction of a material with dilute hydrochloric acid or dilute sulfuric acid solution is hydrogen. Means here the gas obtained by the group 1 when we add hydrochloric acid or sulfuric acid, the gas evolving by the group 1 is hydrogen. It is a colorless, odorless and combustible. Okay, here we added hydrochloric acid or sulfuric acid to group sulfuric acid. No, that time the gas obtained by the group 1 is hydrogen. It is a colorless and odorless and combustible gas. And the gas obtained by the group 2 due to the reaction of a material with hydrochloric acid and sulfuric acid solution is hydrogen sulfide. So here for group 2 also, the group 2 got material. No? That material we divided into 2 parts. So in that one part we added HCl and hydrochloric acid. No? So when we add HCl and HCl means hydrochloric acid and sulfuric acid to the group 2, that time the gas evolving from that is hydrogen sulfide. The gas evolving from that is nothing but hydrogen sulfide. Hydrogen sulfide. It is a colorless gas and with the smell of rotten eggs. So it is a colorless gas and it is having the smell like rotten eggs. Next, you must have observed that the starting material of the substance is same, but the product of the both groups shows the different properties. Okay, so the starting material of the both groups are same, but the product is there, no, that is showing the different properties. Group 1 has carried out the activity involving a physical change. Group 1 carried out their activity by involving the physical change, whereas the group 2 examined a chemical change. So in group 1 they crushed and mixed the two substances. So here the physical change is involved. So whereas the group 2 is they heated the substances. So here the chemical changes takes place. So the material obtained by the group 1 is a mixture of two substances, that is iron and sulfur, which are elements. So group 1 they mix and crush the iron filings and they check the magnetism in the material obtained. So here whereas the group 1 the material obtained by the group 1 is a mixture of two substances, that is iron and sulfur. So this iron and sulfur are elements, and the properties of mixture are the same as its constituents. Okay, the properties of mixture is same as of its constituents, and the material obtained by the group 2 is a compound. The material which is obtained by the group 2 is one of the compound. Why? Because on heating the two elements strongly we get a compound. So we said to group 2 heat and crush the iron filings and sulfur powder and heat it till it becomes red hot. Okay, so here one type of chemical reaction takes place. So that is the material obtained by the group 2 is one of the compound. Okay, so the compound is formed, that property is completely different when you compare with the starting substances. So the composition of compound is same throughout it. So we can also observe that the texture and color of the compounds are same throughout its value. So here the chemical and physical nature of a matter is better to understood by the following flow chart. In this chapter till now we discussed about matter and classification of matter. Next, matter is classified by two ways, by physical classification and chemical classification. By depending on the physical classification, matter is classified into solid, liquids and gases. By depending on the chemical classification, matter is classified into pure substance and mixed substances. And these mixed substances are physically separated. And what are the separation methods that we discussed? So what are the separation methods we discussed in this chapter? Mixed substance means the substance is made up of more than one kind of atoms, then we can call that substance as a mixed substance. So for example, salt solution and sugar solution. So that are the example for mixed substances. Why? Because that contain more than one kind of atoms. That's why we can call them as a mixed substances. So these mixed substances we can separate it by physical methods. These mixed substances again we can classify it into homogeneous mixtures and heterogeneous mixtures. And what is the meaning of homogeneous mixtures we discussed, and what is the meaning of heterogeneous mixtures also we discussed. So once again we will discuss about the definition of these homogeneous mixtures and heterogeneous mixtures. A mixture mixture is an impure material containing more than one element or compound in any proportion. So that can be separated into components by simple mechanical or physical methods. Okay. So the simple mechanical or physical means includes such methods of separation as hand picking, magnetic separation, filtration, distillation, sublimation and chromatography. So we discussed about these separation methods also with some examples. And the following substance when mixed to any proportion it form mixtures. So what are the substances? Like sand and common salt, and sand and sugar, iron filings and sulfur, water and common salt, water and sand, like water and alcohol, water and kerosene, ammonia and water. Okay, so based on this homogeneity, these mixtures are divided into two categories. What are that? Homogeneous and heterogeneous. And what is the meaning of homogeneous mixtures and what is the meaning of heterogeneous mixtures? This also we discussed. A mixture is homogeneous if it has the same composition and property throughout. So we are adding, for example, like lemon juice we discussed. In that we are adding water, salt, sugar, lemon. Okay, so after some time, in that which is salt, which is water, which is sugar, which is lemon, we cannot identify. This composition will be same. Okay, so and property also same. This type of substances we can call them, this type of mixtures we can call them as a homogeneous mixture. Salt and water, sugar and water also we can say example for homogeneous mixture. Okay, so example for homogeneous mixture: sugar in water, alcohol in water, and hydrogen chloride dissolved in water. Air is a mixture of nitrogen, oxygen, carbon dioxide, noble gases. These are all the example for homogeneous mixtures. Next, we discussed about the heterogeneous mixtures also. A mixture is heterogeneous if different parts of it have different composition and properties. For example, when we are adding to our more substances, then we can identify which substance with our naked eye. For example, when we mix sand and salt, so we can observe in that which is salt, which is sand. So these type of mixtures we can call them as a heterogeneous mixtures. Okay, so these homogeneous mixtures we can classify into solutions like solvent and solute like that, and heterogeneous mixtures we can classify into like colloidals and suspensions. Okay, so what is the difference between homogeneous and heterogeneous means? In homogeneous mixtures, when we mix the substances, that we cannot identify one substance is dissolved completely in another one, and we cannot identify which substances are mixed with our naked eye. Okay, in heterogeneous mixtures, when we mix that, in that which we are mixed, that we can observe with our naked eye. Okay, so and the components of mixture may be separated by simple mechanical or physical means like hand picking, magnetic separation, filtration and distillation. For example, iron may be separated from sulfur in a mixture by attracting the iron particles with the help of a magnet. Similarly, sand may be separated from the common salt by dissolving out the salt in water. So when we dissolve the sand and salt water mixture, from that we can separate the sand. And next, filtering of the sand and recovering of salt by evaporation of the solution to dryness. Next, a mixture does not have fixed composition. In other words, we may mix the components of a mixture in any proportion. In every case, it will be mixture. And the melting point or the boiling point of a mixture is not fixed. It is depend on the proportion of the components. For example, the boiling point of a solution of sugar in water is depend on the amount of sugar. So the boiling point of a solution of sugar in water is depend on the amount of sugar. The more the amount of sugar, higher the boiling point. Again, the freezing point of water becomes less than 0 degrees centigrade when common salt is dissolved in it. So the more common salt is dissolved, lower the freezing point. The formation of a heterogeneous mixture does not involve any change in energy. For example, if we mix sand with common salt or iron with sulfur, no heat is evolved or absorbed. There may or may not be a change in energy during the formation of a mixture. Okay, so the formation of heterogeneous mixture does not involve any change in energy. For example, if we mix sand with common salt or iron with sulfur, no heat evolved or absorbed. Homogeneous mixtures that form by a solid and a liquid are that this homogeneous mixture formed from a solid and a liquid, two or more miscible liquids and gases in liquids involve a change in energy during their